So, the ultimate objective is to go and protect data, right, because data is, when processed, becomes information. I take you back to the first module. So, data, raw data when processed becomes information. So, the ultimate objective is that data needs to be protected and it should not be corrupted. And so, then when we want to study cloud, so who manipulates data? It is not the operating system, it is the application. So, the application manipulates data. So, when we look at application level security, we should look at what do you mean by application level security? I need to go and protect the data that is manipulated by the application. So, to understand that in a good perspective, we need to look at the data life cycle. What happens to that data? The data is born and it dies. So, between the birth and its death, it should be kept clear. The necessary confidentiality for the data should be there, integrity of the data should be there, and availability of the data whenever it is required by some application should also be there. Now, when we move from a data center to a cloud, what would be the impact of this cloud on the different phases of this data is what is to be studied. Now, as you see in the slide, you have the data, first it is generated, then it is used, then it can be transferred, then it can be transformed, then it can be stored, then it can be archived, and finally it can be destructed. So, at least there are 7 phases in the data life cycle. What is the impact of moving from a pure data center model into a cloud model, and what would be the impact of this movement on each of these phases if we go and study in detail from a security point of view? That will give us much more of what we are trying to secure when we do the computations through our applications, and that is what we will see in this session. Now, when we look at data security and storage, of course, there is something like the data when it is generated, it can be in transit, that is, it is moving from one location, physical location, to another physical location, and when that movement happens, you need to ensure that confidentiality and integrity is maintained, and we do that using a secure protocol. So, we may also do it with a non-secure protocol, but with encryption. So, any one of this is possible, and when the data is at rest, that is, it is located in a storage in a data center, within a data center, though not advisable, we can store it in some encrypted form. But when we are putting it on a cloud type of infrastructure, it is absolutely necessary, though the cloud service as an infrastructure can say that they will provide necessary isolation, it is in the best interest to keep it in an encrypted form. Now, when we store data in an encrypted form, then some of the known services, right, we don't write our software, but there can be services on the cloud like indexing, searching, etc., that is there as part of the cloud. When we want to use those services which we have not coded, it has been developed by the cloud service provider, how will we do this indexing or say searching on an encrypted database? By using a non-proprietary, that is a generic software provided by the cloud. The cloud, when we hire a cloud, they give certain services which may include this index and search. So, in this context there is a lot of research that is happening. We will talk about these encryption algorithms down the line in our phase 4 or phase 5 courses. So, what does these encryption algorithms do? There is something called an homomorphism encryption. What will the homomorphism encryption do? it will encrypt your data into cybertext, but the data can be analyzed and you can also do some operations on the data like your indexing, searching, as if you can do it on the normal data. So, this is an interesting so I need not decrypt to actually do certain operations. I can use the same encrypted data to do certain operations and basically get the result, and of course, when we display the result there can be post that there could be a wrapper which can decrypt and give you the actual data. So, by having such a homomorphism encryption, what do we achieve? Some generic software which is written which does not have any knowledge about our encryption can be used seamlessly on our encrypted data, and this is very relevant when we look at cloud. The next thing is called predicate encryption. Predicate is nothing but a secret function f. So, I would like to know whether a particular data satisfies some property. So, I have a secret function f to which I give the encrypted data as an input, and if that function evaluates to 1, that means I can say it satisfies that particular data item, encrypted data item satisfies a property. If it evaluates to 0, then it does not, but the function f will be known, it is a secret key function. So, by this what could happen is that I could go, and this type of predicate encryption is something which is generic. I need not do a decryption, I can just go and evaluate some function, and then when it comes out 1 or 0, based on that I will know something about the data, some characteristics about the data which is sufficient for me to do further processing. So, this homomorphism encryption and predicate encryption are two interesting encryption research avenues today, which can basically help you encrypt your data and put it in a common infrastructure and do some operations on that encrypted data without decrypting it. So, this is very important. So, and then there is a need for when you process the data, especially in a multi-tenant model, there is a need for security. So, these are all some aspects when we start looking at data, even at the generation phase as it moves from the client to the cloud. Now, these are that data can be in transit, data can be in rest, and at all stages we need to go and have an encrypted form, and sometimes without decrypting it we can basically go and do lot more operations when we use some specific encryption algorithms, and lot more security need to be taken when especially while processing data, and that too in a multi-tenant model. Now, the other thing is that somebody who doesn't, there should be a sort of accountability for this data to talk about integrity. So, that two terms are introduced from the cloud point of view, what we call as data lineage and data provenance. What is data lineage? The data lineage essentially means that we would like to know when and where the data was located in the cloud, right. So, for example, the Amazon web services AWS gives you for data something like store, the date, time, and from where, and process, restore. So, for the exact lineage from where it originated, where and all it stayed and where it came, that should be available as an audit. So, that at some point of time when I want to go and ensure integrity of the data, and these type of logs are very important. And also the next thing is data provenance. Here we have to go and look at the computational accuracy of the data. For example, if you are doing a financial calculation like 2 into 3 into 4 divided by 6 minus 2, you get $2. Now, the simple thing that you have to notice that 2 into 3 into 4 into 6 is in what currency, and the other 2 minus 2 is in what currency, both should be in same currency. So, if I just say dollar, one can be Singapore dollar, another can be say American dollar. So, I have to get back some correct exchange rate. So, these type of computational accuracy need to be also certified. When we try and use third party software like cloud service provides some software, then there is no way by which you can test. So, these things are something that we need to keep in mind, otherwise this can spoil the integrity of your data. So, when we move from a normal data center to a cloud type of infrastructure, this is one very important thing. So, as you see there in your thought, right, there is where is the system located, what was the state of that physical system, how would a customer or auditor verify these information about systems and their physical state. This is what is a challenge that needs to be addressed, and many of this are taken care of by having logs and also having some very carefully coded procedures. The other important issues when specifically while we are storing data, we go and erase, but is it getting completely erased? Actually, there is a property called data remanence, which is that remaining after the data remaining still after you go and erase a magnetic field, it does not immediately get erased and it will remain for some time. And if I have this data remanence, then some inadvertent disclosure of sensitive information is possible. Though I think I have deleted it, it is not actually deleted, it is still some remnants of those data is still there, and you basically can get some sensitive information. So, so the other thing is that when we move from a normal cloud normal data center to a cloud, all your data, all your file system, since they are going to be on a public place in a cloud, need to be encrypted and then decrypted if necessary, otherwise some homomorphism encryption or the predicate type of encryptions are used. We need to work on encrypted data to do the computations, right. So, the other thing is that to the extent that quantities of data from many companies are centralized, right, this collection can become an attractive target for criminals. So, a cloud is something very interesting for a criminal, because if he gets into that, he is not getting into one company, but he can get into many companies' data. So, the other thing is, of course, we are talking about people, process, technology, people, the physical security of the data center, all the and so data centers are rated as tier 1, tier 2, tier 3, etc., depending upon these features available. So, these are all standard documents. So, there is a tier 1 data center, tier 2 data center, etc. And what do we mean by this? So, the levels of security are higher, and then the people there, the trustworthiness of system administrators and takes very good, and the physical security at data center are prime importance in this effort. When there is a movement from a normal data center to a cloud, the most important thing that comes up, other than the other security we have taken care of, is the identity and access mechanism. What happens when we move from a data center to a cloud, which is more public? Actually, your trust boundary is now enlarged. We were still now depending upon trusting the system integrator. Suppose you have a data center, there is a system integrator for you, there is a network service provider for you. We were just believing or trusting these people. Now the trust is now expanded to the cloud service provider. So, we go into his domain, and from the cloud service provider point of view, he has many clients, each client has many employees, contractors, partners, etc., and so he has to now go and manage the access of this diverse set of population across different customers. And that also, in that context also, when I want to go and access a cloud, the identity and and the related access management. So, I identify a user, I authorize him, he authenticates, and once he is authenticated, how do we grant access. So, this IAM becomes very important as we from a cloud service cloud service provider point of view. So, what happens is, because of many people trying to access this cloud, there is a need for doing lot of authentication, which is more personal. So, there is an increased demand for authentication, and there is also a need for high assurance authentication. It should not be just password, but multiple levels of authentication, and there should be special types of authentication for mobile devices. How to handle this? These are all issues that come. Now, let us go and look at the very important thing of privacy. We have now talked about protecting data, but one important aspect of protecting data is to protect the privacy that the data essentially gives. Now, one of the bigger challenges, like privacy and trust and privacy are not the same, they are different, and as we go down we will see a much more concise definition for privacy. But now, as we said, there is a definition of trust is always elusive. In the previous session we did mention that trust does not have a mathematical formulation. Similarly, privacy also is sort of a very evasive definition is what we can give, because privacy is still not well defined. The concept of privacy will vary among countries. What is private to one country may not be considered as a private information in another country. And what is it? What do we mean by a privacy? I go and assure privacy means privacy is for the entire data cycle. I collect the data, I use the data, I disclose the data, I store the data, I destruct the data, and this data, if it is personal, then there is something that we have to do at every stage. So that gives us, to give a very short, a very constructive name for this, we call this data as a personally identifiable information. So, a PII. So, we have to be very careful about handling PIIs. So, finally, if you note, all this privacy is about the accountability of organizations to the data subjects, as well as the transparency to an organization's practice around personal information. How do we handle personal information? So, the concise definition of privacy is very difficult, but these are all the notions of privacy that we are talking of. Now, we should not mix security and privacy. Privacy is something much more different. We will understand what is the difference between privacy and security by some of the needs that privacy enforces us. For example, there is a need for privacy at the storage stage, at a retention stage, at a destruction stage, at an auditing, monitoring and risk management stage. And then we will look at some breaches, privacy breaches, and who is responsible for protecting privacy. We will look at all these things as a part of understanding privacy. So, we will look at what is privacy from a storage angle. Privacy from a storage angle we have already talked of in great detail, and today when we look at these type of multi-tenant model, I am storing data on the same disk, I am storing data on the same memory, but now there is some virtual machine which is going to provide me this isolation, but will it provide me that isolation is the first consideration. So, the aggregation of data raises new privacy issues, because there will be many customers who will be sharing a particular platform and the same hardware physical platform, and that is going to be a major privacy issue in storage. And so, somebody says that my privacy of data is ensured, then they should really go and prove that there is indeed an isolation in different programs or different virtual machines storing data on storing their data on a single physical disk. So, this is something that needs to be there. And talking about retention, how long is personal information retained? What is the retention policy? Does the organization own the data or the cloud service provider owns the data? Who enforces the retention policy in the cloud, and how are exceptions to this policy is managed? Such as if there is a litigation, I can't go and destroy the data. So, how are these things actually managed? So, this is another thing that we need to take into consideration when we are looking at privacy. And destruction. So, how does the cloud provider destroy? When you destroy, have you destroyed everything, or he keeps a part, he keeps a copy and then destroy, and if he keeps a copy, what will be the implications? So, these are all something that we need to do the privacy at the destruction stage. And the more important thing is about auditing, monitoring and risk management. So, how as an organization, suppose let me say there is a cloud service provider, I am organization A. How will A now go and audit X? When he starts auditing X, X does not have, can I go and audit only my virtual machine, or can I go and audit only my data? So, that is another thing. And do you actually audit it regularly, and what happens when, so how do you go and audit first, and if at all you go and audit, how do you audit it regularly, and if there is an event, what happens if there is an incident here, right? And specifically when business critical processes are migrated to a cloud computing model, the internal security process need to be evolved to allow multiple cloud providers to participate in those processes. So, these include processes such as security monitoring, auditing, forensics, incident response and business continuity. All these things again we have to go and look at from a cloud point of view. Now, this is also a privacy concern, because the moment I am going to audit or monitor, there is a notion that I am trying to sneak into data. So, how is it that in spite of this auditing and monitoring, your data is still your privacy is not breached? Okay. So, in the next session we will talk more about privacy breaches.